Hey everybody, my name's Tyler Smith, and I am a resident in AppZiva's AI and machine learning residency program. I've been doing that for just over close to a year now. About a month and a half ago, I did a workshop for them, and I'll put a link to that in the show notes below. But there I showcased how we can use Google's Gemini model to extract text from an image, using a little bit of prompt engineering, and then using another text-to-speech model or another model, which is a text-to-speech model, taking that text that we've extracted and generating human-like audio. And so, towards the end of that workshop, I made mention that I was currently in the process of fine-tuning a fairly new text-to-speech model, Sesame, and using another text-to-speech model, Dia, uh, using generated audio from Dia, so using model distillation to then generate a synthetic data set and then fine-tuning Sesame with that data, with that audio data. So the what you're looking at now is the curated data set that I use to fine-tune Sesame. And really, where I'm going with this is an application, simple application where you can upload an image with text in it, and that can then generate human-like audio from the text that's been extracted. So this data set, like I said, has been generated. The audio samples have been generated by Dia, and then the text I had to manually go through, create a TXT file from the Vatican website, and all of this is the Book of Genesis minus one of the verses because one of the lines did not upload when I made the data set. So it's pretty much all of the Book of Genesis. And um, yeah, we will go into the and so how I did that was each line of the text file was a verse or like Book of Genesis chapter one, and then the first verse, second verse, etc., all the way down for like the 3,400 verses that I used from the Vatican's website. But when I initially was trying to get the model to work to generate audio, I found out that I had to go in and kind of rearrange some of the verses to make sure that the beginning of the sentence token and there was an ending sentence token, so like a period. So I had to go in there and just make sure that every line was a full sentence. So there might be multiple sentences in a line. There might be just one giant sentence. So that's pretty much what I'm doing. Um, that's pretty much what I had to do to get the TXT file to where I needed it. So then here in this collab, I'm reading in that file. I'm stripping out all the white space, stripping out all the digits that are corresponding to verse numbers because I don't really want those. I don't really want those spoken as we generate audio. Excuse me. And then also substituting out the quotation marks for just a blank space because I recognize or I realize that um, the generated audio was giving a phonetic representation of the parentheses, and sometimes it does that with the hyphen or the um, some of the sometimes it does it with a period because I realized too that when I concatenated some of the verses later on in the notebook, um, that there's not a space between the period and then the next sentence. So sometimes there's a phonetic representation that the model is learning um, for the period instead of just an end of sentence. Um, but other than that, it's not a big issue. It's just kind of it's just kind of funny, really. So that's what we're doing here. To just read that text file and see what we have. Now, the next thing to do when generating that audio with Dia was to make sure that it was north of 5 seconds and south of 20 seconds, or otherwise, according to the documentation, the cadence of the generated audio was going to be too slow if it was under 5 seconds, and it was going to be too fast if it was greater than 20 seconds. So I just kind of had to time myself to see how many tokens I guess I could say in 5 seconds or in a second, and I kind of found it was somewhere around 28. So 28 tokens per the 5 seconds, we're looking at 140, and per the 20 seconds, we're looking at 560. So ideally, we want sentences or clumped verses, I guess, to be somewhere between 140 and 560 character length. So reading that first text file in, we can see that the most of the verses are between 50 and let's say 150. And so we need them more than that. We need them between 140 and 560. So then here we are joining every two verses. And then we're going to look at the distribution of the length here, and we can see now that the uh, the verses are the vast majority of the verses are in that acceptable range. So then I loaded in the DIA model, and then we're going to look at these outliers. So the verses that are theoretically too short, so that should be unnaturally slow, and then the outliers that are uh, too long, theoretically too long, to see if that is unnaturally fast. So what we're going to look at is verse 1 or data point 1 and then data point 12 to see if they sound different.
Then God said, "Let there be light." And there was light. God saw how good the light was. God then separated the light from the darkness.
So that doesn't sound too bad. And then we're going to look at this one that's theoretically too long.
So God blessed the seventh day and made it holy, because on it he rested from all the work he had done in creation. Such is the story of the heavens and the earth at their creation. At the time when the Lord God made the earth and the heavens, while as yet there was no field shrub on earth, and no grass of the field had sprouted, for the Lord God had sent no rain upon the earth, and there was no man to till the soil. But a stream was welling up out of the earth and was watering all the surface of the ground. The Lord God formed man out of the clay of the ground and blew into his nostrils the breath of life, and so man became a living being.
Nothing not too bad either. It's there's a few spots in there where it gets a little fast, but all in all, it's pretty good. And then here's just a um regular length.
Chapter 2. Thus the heavens and the earth and all their array were completed. Since on the seventh day God was finished with the work he had been doing, he rested on the seventh day from all the work he had undertaken.
So then moving on to creating the creating the metadata for the fine-tuning process. According to Dia's documentation, we need an S1 and an S2 every other speaker. So what I did here was just made an S1, S2, S1, S2 every other speaker for the length of the data set, which is 664, I believe. And so this code block here then just says make it S1 or S2. Oh no, sorry. It's just S1, S2, S1, S2, and then with the verse that we're looking at. So every other verse in that 664 is going to be S1 or S2, and then it's going to create. And this actually ran for 12 hours for this to finally generate all the audio. And then using all that audio, we then create a JSON file. I then uploaded that I ended up storing that in my Google Drive as the metadata JSON, and then reading that back in. We see that we have our metadata file for the fine-tuning process where the text corresponds with where the audio file is within my Google Drive. And so once we have the metadata file, we can then use a train test split to then create a train and test JSON file, which the fine tuning or the Sesame fine tuning process will use. And then after the fine tuning process, I believe I used this experiment 13, 25 epochs. Yes, I used this one right here, um, to then use the model weights for the application that I will hopefully be getting done fairly soon. So let's take a look at this.
Midway through the journey of life, I found I had strayed from the path within the dark wood.
So yeah, that was awesome that it worked and that it sounds pretty human-like. And then just to make sure that I can pull the um, data set from Hugging Face and then use it locally. We're going to load the data set using the um, load dataset module from datasets using the dataset name. And I did not split it into a train and test set, which I probably should have done, but as I'm gonna get to here shortly, that you can use a method from the dataset class that lets you separate into a train and test split if you want to do that. So we're playing. I'm gonna play some of these to make sure it works.
Then God said, "Let there be light," and there was light. God saw how good the light was. God then separated the light from the darkness.
Perfect. And then just to give you kind of I guess an example of the audio learning to have a phonetic representation of hyphens or periods. I think it's one of these two.
God called the light day, and the darkness he called night. Thus evening came, and morning followed the first day. Then God said, "Let there be a dome in the middle of the waters to separate one body of water from the other." And so it happened. God made the dome, and it separated the water above the dome from the water below it.
So maybe it's this one.
God called the dome the sky. Evening came, and morning followed by the second day. Then God said, "Let the water under the sky be gathered into a single basin, so that the dry land may appear." And so it happened. The water under the sky was gathered into its basin, and the dry land appeared.
So yeah, we can see that it learned some sort of phonetic representation for this hyphen and then this in this period here. But all in all, what I'm just looking or trying to obtain here is just human-like audio, and that is what we have. So, and like I said before, we have the data set. If you save your data set, you can just use the train test split method, and give it a test size of 30% like I did here. And so you have a training size of 464 and a test size of 199. And yeah, then you can use it yourself and use it on your own project. So thank you for listening. And if you have any questions or comments, I will leave my LinkedIn profile at the bottom of the show notes to if you want to get a hold of me. And um, yeah, hopefully I can get that application working, and hopefully I can make another video here soon. So thank you all. Bye.